there are two ways you can describe this force. Let's say this is a certain amount of Newton. So, but both of them, there is one important thing you need to give me. What is the coordinate system you're using? Most of the time, we're using horizontal as our x, vertical axis as our y. That's trivial. And in order to get that, there are two ways you can say, you can describe. One is, okay, I'm telling you I have a force which is certain amount of the Newton, let's say 10 Newton, and this 120 degree from the horizontal axis. So in that case, you know the direction, you know the magnitude, and that's fine. And if you don't like that, you can say, I want to do okay. So in this case, what are you going to have? Let's say this is equals to 1 Newton. So if you do that, this is going to be negative 2.5 Newton. This one is going to be 4.33. Same for velocity, same for acceleration, same for force. If you have a vector, you can present things like this, or one way is using this one, the other way is using this one. Or you can use vector representation, which is f equals to negative 2.5 I plus 4.33 J Newton. This is vector representation. I'm not so sure how many of you guys know how to do this in the past. But I'm going to tell you, if it's going to be x direction, it's going to be I. If it's going to be y direction, it should be J. Okay, so this is x, this is y. And right hand side is going to be my positive. Upward is going to be my positive. That's trivial. So if I'm using coordinate system like this, then you should be expecting the negative sign in front of your number is going to be the left hand side. The positive number over here is going to be upward. Okay? Now, when we are doing vector representation, there are two ways of doing that. One is using geometry method. The other one is using the number. You decouple everything in terms of x and y, then add them together. So when you try to find the resultant or the total force of that thing, you just use this equation to get the total force. So either way, it's going to work. Right.
Tomorrow, do you have an extra job?
No.
No?
Only one.
One piece?
Yeah. I go upstairs and ask for this.
Okay, all right.
Okay. So I have A and B. Two forces. I want to add them together. There are, based on that part, there are a few ways we can do it. Geometry-wise, A, B, that's my R. Any question? Geometry method is that simple. Or, if you don't like that, A, you just put the starting point at the same position. B, and do a parallel of it. That's my result. Or you don't like both of them. You can say, hey, I I would like to use the vector representation of doing that. So I define as a theta as B. So my A is going to be my A cosine theta I plus my IA sine theta J. My B is going to be my B cosine B I plus B sine B J. So my R is going to be x add to x, y add to y. A cosine B plus B cosine B. Well, my B should be plus A sine theta plus B sine B J. Okay? So, either way, you can do that. But if you do need to use geometry method, then there is some other thing you need to remember. Okay? They are law of cosines. So if I have A, B, C, and I have angle A, B, C over here. So when I have law of sines, what do I have? I have A squared equals to B squared plus C squared minus 2BC cosine A. So if I want to know the length over here, it's going to be the square of here and here minus 2BC cosine this thing. That's my law of sines. Which means if I want to know B squared, the length of B is going to be A squared plus C squared minus 2AC and the corresponding angle, which is B. If I want to know the length of C is going to be A squared plus B squared minus 2AB cosine. I believe you guys know this formula. Maybe recently or a long time ago, but this is refresh your memory. Okay. And the other thing we need to, so if you know length, you know only one angle. Law of sines, law of cosines might be the easiest way to do it. But sometimes you only have lengths, you might have some angles, and you need to use some specific combinations. There is another set of formula, which is law of sines. Okay, law of sines saying that A divided by the corresponding angle, sine value, equals to B okay. So in other words, if you try to find the resultant of this force, you know the angle of this thing. You know the angle of this one. What are you going to do? Find the angle of this. Then since you know this length, you know this length. what are you going to have? You're going to know the resultant over here. How do we find this things over here? We know this theta A. This is also theta A because they are in parallel. So this angle over here, let's name this one phi. Phi is going to be what? 180 degree minus theta A minus theta B. Can you find the R, the resultant of this for combination over here? You can, right? Because if you can find out B over here, R equals to A squared plus B squared minus 2AB cosine B. Does that make sense to everybody? Okay, so I should give you this number and give you B over here. So in that case, you know theta A, you know theta B. So when you know theta A and theta B, this angle over here is going to be 180 minus this angle and this angle. So with that said, we know law of cosines. Then you should be able to find out the resultant over this combination, which should be straightforward. Okay. If you don't know what I'm talking about, you need to do a little bit practice because you might forget those kind of combination. You need to refresh your memory. Okay. Other than that, there is one other thing I would need to remind you. If you are dealing with vectors and it's only the combination of two vectors, I would suggest you consider either vector representation like this or using geometry method. That's both one. Okay. If you try to use geometry method, you need to know law of cosines and law of sines. You need to know the formula. I'm not going to give you those formula to you when you are doing the exam, so you need to remember that. Okay. But if you have three vectors, let's say I have vector over here, I have vector over here, I have vector over here, A, B, C. I wouldn't suggest you using geometry method to find the resultant of those three forces. Because you might say, hey, I just use this one, and this one, and this one. Well, concept-wise, it's correct, and you just do this. Right? No big deal. Right? However, when you are using this combination, you have four forces. Law of sines and law of cosines won't apply. You can only apply this thing after you calculate the combination of A and B, so you find the resultant of A and B. Then use that as an independent force. Combine that with C. So in that case, you can use this. But I can almost ensure you, if you have more than two forces, you try to use geometry method, it's going to be more tedious than using vector combinations because you just need to decouple everything in X direction, Y direction, and add them together. So rule of thumb, if you have two forces, it's up to you whether you want to use geometry method or you want to use vector representation. But if you have more than two forces, use vector representations because it will be easier than using geometry combinations. Does that make sense to everybody? Okay. first question based on chapter 1. What kind of unit I'm dealing with? Is that English or is metric? Okay, so you know it's metric. So when you are deal with this kind of things, do you need to deal with 9.81 or 32.2? No, because it's force. It's not weight. It's not mass. So never use those kind of things. Okay, with that in mind. Normally, when I'm solving the problem, I would like to do one thing. One is define what are given and what I need to find. Then start my solving procedure. It's important for you guys to identify what are given and what you need to find, because you are rephrasing the whole problem yourself, and you can make sure you understand the problems by writing down those 2 points. Okay? So in this case, I know I have 2 forces. So I probably want to say, okay, this is my P. So in that case, I know my P is 6 Newton. My Q is 50 Newtons. One other information you're having here is, if you want to say this is theta Q, this is theta P. You can also say theta P is 23. Theta Q is 33. But I didn't specify the directions of these 2 things over here. This just make yourself understand what the problem is asking for. Right? And I need to find out the resultant. When you try to find resultant, keep in mind, you need to have 2 pieces of information. One is magnitude, the other one is direction. Okay? So I'm going to solve this problem using 2 ways. One is using geometry method. The other one is using vector representation. So when I'm using a geometry method, I'll do it here. This is my P. And the magnitude over here is what? 16 Newton. And when I have this one, the other force is going to be next to the end point of the first force. So it's going to be what is the magnitude over here? 15 Newton. So I would like to know FR. So can anybody tell me which laws I should apply over here to find the force of FR? Law of size or law of cosines? Suggestions? Don't be afraid, I won't bite. Law of size, law of cosines.
Cosines.
Law of size, yes, that's fine. Okay, so if you want to use law of size, so what are you going to do? You need to find the angles. And I know this is 20 degrees. I know this is 30 degrees. So can you find this angle? 180 minus 20 minus 30. So this angle over here is going to be what? 133. So if I want to use law of size, I need to know, I don't really know the angle over here, right? Even though I know the force over here, I know the force over here, but I don't really know those 2 angles. So it may be a little bit difficult for me to find out. I know more lengths than angles. So in that case, I would like to use law of sines, law of cosines, because law of cosines deal more lengths rather than angles. If you have more angles, then you want to use law of sines. Okay, so that's a little bit different, but you need to know the trick. like to apply law of cosines. So over here, I will need to use FR squared equals 2p squared plus q squared minus 2pq cosine p. Let's name this one p. Do I know p? I do. Do I know q? I do. Do I know phi? Yes, I figure out. So I find my FR. So in this case, you're going to find FR equals to 99.78. Is that enough? I said, if you want to find out the resultant, you need to have two pieces of information. One is magnitude, the other one is what? Direction. Does this one give you any direction? No. In order to get the information of direction, you still need to find the angle. So when we try to find the angle, we know all the lengths, this length, and this length, and we also know this angle over here. So the other two angles can be found using what? Law of sines. So if you use law of sines, then certainly you're going to find out the angle over here. Then you should be able to know, since we know this is 20 degrees over here, so we should be able to know this small angle over here. Does it make sense to everybody? So what I mean is, you see this horizontal axis over here, right? And this is P. P has 20 degrees corresponding to the horizontal axis. But this point, you started to FR is greater than 20 degrees. So if you use law of sines, let's name this one as theta FR. FR over sine 180 degrees, which is here, is going to be that is Q sine 20 degrees plus theta FR. Does that make sense to everybody? Is that everybody understand what I'm trying to do? So this is law of sines. So I know the angle over here, which is 130 degrees. I also know FR, which is something I calculated from here. And I know this is 15 Newton by Newton. And this is going to be 20 degrees plus this small angle. This small angle is actually the direction of my resultant force. Okay? So if I do that, FR equals to what? 99.78. Q is what? 50. How many unknowns we have in this equation? Just one, which is this one. So if you do that, you're going to find theta FR plus 20 degrees. By doing the calculation, so sine 20 degrees plus theta R is going to be Q over FR multiplied by sine 170 degrees. This is going to be 50 over 99.78 sine 180 degrees. So if you take the inverse of sine of this value over here, you're going to find 20 degrees plus theta FR equals to 22.57 which means the angle of theta FR is 2.57 degrees. So with that said, if you have force pulling over here and and another force pushing over here, the resultant over here is going to be this force, 99.78 Newton, with an angle, the small angle over here, which is 2.57 degrees. Be sure you draw it. Okay? Is that clear? Everybody understand what I'm doing? Now, this is one way of doing it. Sometimes, most of the times, I don't prefer using this way. I would prefer to use vector representation. So if we are using vector representation, if I'm using vector representation, what I'm going to do is going to decouple everything P into 60 cosine 20 degree I and 60 sine 20 degree J. Q is 50 cosine 30 degree I 50 sine 30 degree J. Newton, of course. Now, one thing you might notice is that I haven't put plus negative sign in front of all the numbers. That is something we need to determine over there. But in this case, this is my P, and this is my Q. Right? And typical presentation, vector representation is going to be right-hand side positive, upward positive. So in this case, is my P, the x direction of P going to be positive or negative? Negative, right? How about Q?
Positive.
Negative. So when I'm doing the vertical force, what is this one? Is this positive or negative? For P. Positive. How about this one? Negative. So nothing fancy. If you try to find FR, you just add those two numbers together, you get your answer. And both of them are negative, so the answer you're going to get is going to be negative 99.68 I. Over here, you're going to find it's actually negative 4.48 J. What is the unit over here? Newton or pound? Newton. Be sure you do it. Okay. You might notice one thing different when I'm dealing with this answer over here. For geometry method, the answer I have including both magnitude and angle. But when you are doing vector representation, you don't need to do that, because you clearly specify how much force is on horizontal axis, how much force is on vertical axis. So it means that by using this magnitude and this magnitude, we should be able to know the angle by using arctangent information of here. So if you are using vector representation, you just put all the numbers in I and J. That's enough. You don't need to convert everything back to angle unless I specify. This is enough. But if you are using geometry method, this is not enough, because I only know the magnitude. I don't know the angle. This one giving me the magnitude and angle simultaneously. So in most of the cases, if you try to do graduate school in the future, people will use this thing instead of this when you are writing down technical papers. Does that make sense for everybody? Any questions?